So after these two lessons on data abstraction and object-oriented programming, we can ask the question, where is it all going? With object-oriented programming, well, data abstraction languages, not just object orientation, have an enormous literature, platforms, applications, industrial support. It's just enormous. And these two lessons, so I've tried to distill the essential things in 2 hours. The three main principles: data abstraction, polymorphism, inheritance. And in fact, the principles of data abstraction are well established. And in my view, they will stay well established. They are fixed points of progress, and we will go beyond them, but we will not question them. I think it is definite progress in understanding how to build complicated systems. But what will advance is things that go beyond the currently existing principles. For example, object-oriented programming is traditionally focused on sequential, centralized programs that run on one machine, and programs that have very few threads, very little concurrency. Concurrency support is very bad. Distribution support is very bad. Nowadays, we need this concurrency support. We are really seeing a strong push toward long-lived distributed systems called services, implemented in many different ways, including on clouds, but also peer-to-peer. This requires new concurrency abstractions, not just transactions, and certainly not monitors. This requires support for fault tolerance, also security. This will require language support. How can we make sure that security cannot be broken into? It's a global property, but the language plays a key role. Also, resource management goes much beyond single operating systems on single machines. Finally, a point that has been traditionally sort of pushed in a corner: configuration management. How to manage a system that is changing its architecture, changing its structure without stopping the system. So component-oriented programming, going beyond objects. For this, there are some influential language developments, particular Scala, which combines functional and object paradigms in a very nice way and has a very good message passing concurrency model with support for transactions distribution and interoperable with Java. There's also Erlang, which has a fairly long history, like Java, but is quite advanced beyond its time in those days, and nowadays it's coming much more to the foreground. It has message passing, support for very high availability, which means that you can always access the service, even if you have software faults or hardware faults. And there are many other interesting experiments that I'm not going to mention. So myself, I'm in projects doing interesting experiments in this area. A final point is large-scale distributed programming. Single machines are disappearing, are vanishing. Most applications now are distributed applications, including cloud-based, but also peer-to-peer, including big data applications, which are extremely data-intensive, where the locality of data is important. This is all pushing the limits of data abstraction. How does data abstraction work in a distributed environment? How can data abstractions cover multiple machines, evolve over time? So in my view, what's going to happen is that the basic structure of data abstraction languages will change significantly, while the main principles of data abstraction, polymorphism, inheritance will stay. That a lot will change. The languages will support loosely coupled systems, where systems can break off and come back together. Already we're seeing this in services. Interoperability, such as semantic interoperability, components that are trying to talk to each other, so there will be some notion of meaning, semantics. Semantic web is pushing this direction. Of course, distribution, which will become all-encompassing, and security, which tends to be kind of neglected, but in fact will have to enter the language, not just access control lists, but using concepts like capabilities that can be supported in a language sense. So I think that while data abstraction languages have made a solid contribution and have well-established basic principles, there is still going to be an enormous development, future development on these languages, and in the next 20 years we're going to see major changes in how we program large-scale applications.